Well, my presentation has the following structure: a brief review of the national electric system and the coordinador, and why we need to address resilience and flexibility. Then we will get into a description of risk factor conditioning the operation of the Chilean electric power system and how they become the cornerstone of the design of the future grid. To conclude with some takeaways and recommendations from the perspective of an independent system operator. Uh, Although Chile is on the southern edge of South America, electrically it is an island. It does not have a strong interconnection with other systems. The system covers a length of about 3,000 kilometers at voltage levels ranging from 66 to 500 kV. The geographic arrangement of generation is characterized by a strong solar and wind component in the northern part of the country, plus a relevant thermal generation fleet. In the southern part of the country, hydroelectric capacity, reservoir, or run-of-river power plant stand out with a growing wind generation. The installed capacity at the beginning of 2024 reached more than 34,000 megawatts, according to the project pipeline for 2025. An additional 8,000 megawatts should connect to the system. In the case of solar generation, by the end of 2024, we should exceed 13.3 gigawatts of installed capacity. And regarding demand, the maximum value record in 2024 was around 12,000 megawatt hour per hour, with a total annual demand that reached around 83 gigawatt hours. Our electric power system, or our Coordinador Eléctrico Nacional, is an independent system operator since 2017 and integrate the former system operator SEDEXIC and SEDEXIC, originally created in 1985. And the main objective of our entity is preserve the secure operation of the power grid at minimum cost and guarantee the open access to the transmission system. Well, power system will need to be more flexible and resilient. Innovation is a key element for the success of transition process and decarbonizing the energy sector. An integrated innovation approach needs at least 4 dimensions: the system operation, the market design, enabling new technology, and based new business models. A set of emerging technology solutions that have a significant impact on the decarbonization of the energy sector is a priority for innovation. A special approach will be needed for the expansion of emergency technology, such as green hydrogen and grid former inverter spare resource. On top of that, resilience should be considered as a design element in the transition to a sustainable, safe, and cost-efficient system. Well, let's take a look to the risk factors that affect our electric power system. Here we can see some examples of source of risks to the power system. It's split in 2 categories. The left side is related with natural events, for instance, earthquakes, tsunamis, volcanic eruptions, and some events that are driven by climate change. I mean, wildfire, floods, droughts, and severe storms. In the right side, we can see some events related with infrastructure, systemic and human events, for example, forced outage of equipment, generation unit transmission lines, human errors, cybersecurity incidents, sabotage, and volatility of international and domestic markets. Here we have 2 examples of earthquake affecting in different scale the power supply in the system. In the left side, we can see the event known as 27F, registered in February 27 of 2010, with a earthquake of 8.8 magnitude. It's the sixth place in the top 10 of events in the recorded history. And we experienced the last total blackout of the system at this time, this day. On the other side, we can see a more recently event registered in September 16 of 2015 at the northern part of the country, at Coquimbo region, that caused a brownout, not affecting primary equipment, transmission system, nor generation units. And well, the following slide shows the effects of flood in the northern part of Chile. This kind of event affects mainly the distribution facility and usually take a long time to recover the supply to the residential final consumers. On the other side, wildfires represent a major risk during the summer season. A few weeks ago, we have affected by a huge event in the zone of Valparaíso, Villa del Mar, and Quilpué. And we have very concerned, especially of those events affecting transmission lines corridors. To face this kind of event, we have to take security measures in order to decrease or control the power flow on this facility, and in some cases, to disconnect lines when the firefighters are near or below a transmission line. Technology allows to make nowadays an overlapping display of georeferential wildfire and transmission facility in order to assist decision-making in real time. Another feature of our system is related with climate change and hydro generation availability. We passed from a 12-year dry spell to a very wet 2023 winter, and characterized by a series of extreme rainfall events affecting road and reservoir infrastructure and also people. The upside of this kind of event is an increase in reservoir levels and the energy availability during our snow melt season. Well, let's move now into some conclusion and recommendations. Well, designing the power grid of the future have to be driven by stability and security. The operational condition that will arise in the coming year will necessarily require that the design of the power grid considers a substantial leap in its level of security, strength, flexibility, and resilience. The grid will have to support increasingly complex dynamics in the transition from the use of synchronous resource to inverted-based resource, and the increasing integration of energy and of distributed energy resource. It will be necessary to face challenge in the stability of the electric power system introduced by a high instantaneous participation of variable renewable energy in weak system, with low participation of synchronous generation, as in the case of the Sistema Eléctrico Nacional. The path to the electric power system of the future with 100% participation of renewable energy must be carefully designed to ensure a secure and economical operation at all times during the transition. Designing the power grid of the future, I tried to depict 4 drivers. First, that the magnitude of the challenge and the scope of the work to be done in order to materialize the required change, and the need to coordinate action in different areas, including, among others, planning, regulation, investment, engineering, development, and operation. This accelerated pace of the changes underway and the risk that a disorderly, restricted, and efficient transition will pose for consumers. The high risk for the operation of the system if action is not taken in time due to the lack of adequate tools to securely, reliable, and cost-effective manage the new operational condition that which arise in the electric power system. And well, the system must be prepared for anticipate, absorb, adapt, and recover for a non-routine disruption, including high-impact, low-frequency events in a reasonable amount of time. That is mainly a very broad definition of resilience. Finally, well, the challenge of achieving a net zero emission energy market by 2050 involve a resilient, reliable, and secure ecosystem, which will imply at least improving the design and development of complementary infrastructure, incorporating new criteria, development of transmission and distribution infrastructure with new standards, the commissioning and recycling of fossil fuel-based generation assets. Construction of new renewable power plants should consider design that are resilient to natural events, develop containment capacity for global events, pandemic, war, financial crisis. Digitalization in the incorporation of new technology in electricity system requires also the capacity to react to cybersecurity event. And finally, it is crucial that this new inverted Bay resource provides complementary grid attributes and ancillary service in such a way that they provide the feature of synchronous generation. For instance, inertia, frequency control, short circuit, and black start capacity. Thanks.